Okay, so now we're off to chapter 7. And we're going to start off with something that you guys all totally remember from Calc 1, right? And that's the product rule. Can you guys tell me what the product rule is?
Well, since we're doing f of x and g of x, so we kind of like separate it in a way. So the product would like example would be f of x times g of x, f prime of x times g of x. And you add that with the regular f of x times g prime.
Cool. So yeah, so it's going to be f prime of x times g of x plus f of x times g prime of x, right? That's the rule that we all know. Now, for integration of this, and I just happen to write it opposite of you. You see that? It's the same thing, but I wrote the second term first and the first term second, but it doesn't matter. Since it's addition, it's one and the same. We can integrate this, so when we have the sum of products, we can integrate those things to create something where we can integrate products, okay? So what ends up happening here is the integral of the derivative is the original function, correct? Right? Because integration and derivatives are inverses of each other. Do you guys all agree with that?
Yes.
Okay, since that's the case, we already know the answer to this by looking above. What did we take the derivative of? We took the derivative of f of x times g of x, correct? So that tells us that this should be equal to this. Are we in agreement?
Yes.
Okay. Now, we also know that the integration of a sum is equal to this integration of each of the summed terms, correct? From Calc 1?
Correct.
So we know that the integral of, and I'll just write it how she did it. F prime of x, g prime of x. Ooh, mistake. Let's not make these mistakes. We can go f of x, g prime of x, dx is equal to f of x, g prime of x. So basically what I'm trying to demonstrate here is how we can derive the integral for products, okay? So now what I'm going to do is I'm going to manipulate this in such a way that it helps me to create a new formula. So what do we see here? We see the integral of f of x times g prime of x dx is equal to, and we have that here, right? Don't we have this piece here, right here? Right?
Yeah. Yes.
Okay, since we have that, then that means that this needs to get moved to the other side. Agreed? So we should get f of x times g of x minus the integral of f prime of x, g of x, dx. We okay?
Yes. Yeah.
Oh, okay, so now what we end up doing here is this is how to integrate products. And we end up changing this just a little bit. We don't like using these long, cumbersome things. So we're going to say that our u is going to be f of x, and our dv, or our v, is going to be g of x. Okay? So what ends up happening is the derivative of v is g prime of x dx, correct?
Correct.
So this whole long term ends up becoming this formula here, which is the shorthand for what we're going to do. And you can see it, right? If I take this thing and follow the process that we had above, we have f of x times g of x, that is u times v, correct? Then minus and minus, we're going to have our v, which is g of x, which is right there. And I want to make this, I want to do this correct so you guys can all see this. I didn't put this one in. du is f prime of x dx. And so we see f prime and dx is this guy here, and that's my du. Do you see how it's just substitution?
Yeah.
Okay, so this is going to become very, very important. And we can see that over here, look at the dv, g prime of x, g prime dx is this piece, that's dv, and u is the f of x. So this is how we generate this integral, which is the integration by parts piece. u dv, the integral of u dv is equal to uv minus the integral of v du. Huge. Remember that thing I just highlighted, okay? Sorry, I got a mosquito. I don't know how I had a mosquito in my house, but thank God I killed it. Okay. Sorry, guys. Okay, now, are we okay with this? Do you guys understand from going from the product formula, the product derivative, to the integration by parts piece? Are we okay with how I derive that?
Yes.
Okay, now we're going to do some problems. I'm going to do a series of problems. And it's important, and maybe I should talk about this even before I delve into doing these problems. How do we decide what is U and what is V, right? A lot of people run into an issue with that. And I'm not that smart, but I had a professor that really was. And so he taught me this. So latte. Just remember it. It's almost like a latte. And the way that this works is it goes like this. So this is for selecting your U. Logs, inverse trig, algebra, trig, exponentials. This is the order in which way from top to bottom that you choose which is going to be your U.
Professor?
Yes.
Have you ever heard it as I late?
I late?
With the I becoming before the L? Like the I and the L switched?
No. No.
I think I've heard it like that before, but I'm not too sure.
So it'd be interesting. We can do a problem where we can try it both ways and generate it. One of the things that's funny is logarithms and exponentials are essentially the same thing. So sometimes there's no E because E falls with logs. So I do know that, but I've never heard of inverse trig before logs. Interesting. We can try one. We can try one. But this is the order that I've done, and it's always saved my butt. So I think I'll stick to this one for now, but I'll try some problems that way and see. Okay, so let me demonstrate this. So do you guys remember the order that I gave you? This first one's logs, inverse trig, algebra, trig, and then exponential. Okay? We're all right? Okay.
And this is to pick U or DV?
I'm sorry, what's that? Say that again?
The acronym that you gave us, is that to pick U or to pick
Correct.
DV?
This is to pick your U. So this is the order for picking U. Now, how many of you guys were super strong at integration? Wow. All right, so we have some work to do. This chapter is gonna be, you're gonna have to put in some time because I'm teaching. Integration is gonna come into play big time. Yeah, crickets, right? It's gonna be big time because if integration was an issue, this is rapid pace. So this weekend, really put in some time trying to remember your integration and your derivatives, because what's going to happen in these next 5 sections is going to be, you're going to remember some stuff. Okay, so let me go ahead and set up this first problem so you guys can see the order. So what should be my U in this case? Because we do have a product, right? We have x times sine of x dx. So what should be my U? What do you guys think?
Would it be x?
Okay, so very good. X is algebra. Sine of x is trig. So algebra comes before trig. Okay? So then that means this should be x. And then my dv should be sine of x dx. Right? So that's the rest of it. So u times dv should be the integral that I'm trying to do. Right?
Right.
Okay, cool. Now what I have to do is I got to go find du and I got to find v. Because remember, I need to know all the parts. I need to know u, I need to know du, I need to know v, I need to know dv. So that means that on the u side, I have to take what? I have to take the derivative. So this is going to become du is dx. And over here with the dv, what do I need to do? I have to take an integral. Does that make sense? So this ends up being an integral on this side. And so what is the integral of sine? What was that, Mark? So the integral of sine is what?
Would it be negative cosine x?
So that's right. It should be negative cosine of x, right? So on this side, remember, this is the derivative. And this is the integral, right? Now,
Right.
Just remember that's the process. Now we need to know the formula, and the formula tells us it's uv minus the integral of v du is going to be our solution. So what's my u? My u was x. What's my v? It's a negative cosine of x. So now I'm going to put the negative there. There's a minus sign. The integral, what is my v? My v was that negative cosine. So now that becomes a plus. And then my du, which in this case is dx. Agreed? Or was that too fast? It's okay if it was too fast. Please speak up.
It's pretty straightforward.
Okay, I just want to make sure that everyone's okay. So then from here, I'm going to get negative x cosine of x plus, what's the integral of cosine?
Sine x.
Awesome. So this is going to be sine of x. And now we're dealing with indefinite integrals here, right? We don't have an upper and lower bound. And since we don't have an upper and lower bound, what do we need?
Let's see.
Plus c. That's our solution. Are we all right?
Yes.
Okay, cool. Cool. All right. So let's continue. Now again, with this problem, I'll write it down. In fact, every time I do these problems, I write it down. Every time. Just because I want to get in the habit of, all right, what's the order? And if I know what the order is, then I don't have to trip. Right? It's just nice to have something there that I can rely on, that's going to be easy and trustworthy for me to be able to do. So in this case, what's my u? There's what? Did you say x?
Yeah.
It's not x.
Oh, I see. Yeah. It's natural log.
Yeah.
Very good. I mean, not.
All right, so what do you guys think? There is a product here. Always remember, and this is crazy, every integral that you've ever done, you could do with integration of parts. Every single one. It becomes tedious and lame, but you can do it that way, and I'll show it to you guys at the end, okay? In this product, we have ln of x and we have dx. Okay? So, ln of x is what?
Natural log.
Well, yes, but it's a log. Since it's a log, my u is going to be that ln of x. We okay with that? So then my dv is dx. Now, what is the derivative of ln of x?
1 over x.
Very nice. It's 1 over x dx. What is the integral of v, of dv?
X.
So the integral of dv is v. The integral of dx is x. Okay? Then again, I'm just going to do this because I'm in the habit of it. uv minus the integral of v du. So my u is ln of x. My v is x, so I'll just put it in front of the natural log, minus the integral of x and du, which is 1 over x dx. So that's going to give me x ln of x minus the integral of dx. And that's going to give me x ln of x minus x plus some constant c. What do you guys think?
I think I understand it, sir.
All right. Yeah, it's not too bad, but the building blocks, right? As I start to give you harder and harder integrals, you're going to be like, oh, Lord, what is this guy doing to me? All right. So let's do a little bit tougher one. again, what is this going to be? What should be my u?
Your e to the t.
I told you that exponentials can be treated like logs. We could do it that way. But according to the order that I have, algebra reads exponential. And I'll tell you why in a second.
It should be e?
So this is going to be u should be t squared, dv should be e to the t. And I'll show it the other way so you guys can see it that way if you'd like. It ends up being a little bit more work, which sucks. This way's actually easier. Because when I go du, don't I get 2t dt? But what's the integral of e to the t?
It's just e again, right?
Yeah, it's e to the t, right? It's itself. So that's why it's easier to do it this way, because if I would have done it the other way, just so you guys can see, if I would have gone this route, now this becomes e to the t dt, but this becomes this guy, and it just becomes more tedious. Right? And the answers end up looking different, but they're one and the same. Now from here, uv minus the integral of v du, I'm going to get t squared e to the t minus the integral of v, which is e to the t. But now I need a t and a 2 dt, right? Because that's my du. What do we notice here? Don't I have a product again?
Yes.
And since I have a product again, I have another uv to do. So I'm going to have u is t, dv is e to the t. So this is going to be du is dt. This will be v is e to the t right here. And so I'm going to have t squared e to the t minus 2 times t e to the t minus e to the t, well that should have a dt there, dt integrated. So that's going to give me t squared e to the t minus 2t e to the t minus 2 e to the t plus some constant c. Now, something that should trip you out. It was the integral of t squared e to the t, and yet that's part of the answer. Isn't that weird? Did I just make too big of a jump for you guys?
No, I think I still get it.
Okay, good. Now, the important thing is to notice that when you have a product again, we should use our integration by parts. Okay? Now I'm going to take you on a journey. Do you guys have it down so I can move on to the next problem?
Yeah, I have it down.
Okay. All right. Focus, my friends. Ready? So in this problem here, again, what should be my u?
Sine x.
So according to what we have, it should be sine of x, right? And then my dv should be e to the x dx. Agreed?
Agreed.
So then du is going to be cosine of x. And you see how this starts getting a little bit funky? In the previous problem, we were doing the integration of sine and integration of cosine. So the integration of sine was negative cosine. But now in the derivative, it's just cosine. You're going to have to be very careful about your signs because they're going to interchange these guys like crazy to try and get you to make sign mistakes. Okay? So be careful. And then this is just going to be e to the x.